All right, this is the first video of two you'll be using to complete the Sedimentary Rock Lab. So before we actually get to the lab, let's go ahead and review a few things that you learned in the lesson for the lab. All right, so we've been working our way through the rock cycle, and so far we've gone from magma to igneous rocks, and then igneous rocks to sediments. Now we're working on this part, sediments to sedimentary rocks. So the majority of sedimentary rocks are what you call clastic sedimentary rocks, and they go through the process of lithification. So sediments are deposited and then they are compacted and cemented together in the processes of lithification to form sedimentary rocks. The majority of rocks here in the Shippensburg region are sedimentary rocks, and some local rocks you'll be looking at in this lab. So a basic definition of sedimentary rocks is these are rocks that form from the lithification of sediments. So if we go back through some of the material before reaching sedimentary rocks, we learned about weathering, and then the erosion and transport of the sediments that were formed through the processes of weathering. And then after transport of the sediments are deposited. And then after deposition, the sediments may or may not eventually become a sedimentary rock. It all depends on whether or not they get buried and then they are compressed and cemented over time. So sedimentary rocks are rocks formed from weathered products of pre-existing rocks that have been transported, deposited, and lithified. And on the screen there, you see is a diagram labeled with several different types of lithified sedimentary rocks: conglomerate, sandstone, siltstone, and mudstone. Limestone is shown there as well, and most limestones are in another category that we'll be doing in the second part of the lab. All right, so if we look at the process of lithification, lithification is the process where these sediments are transformed into rock. So there's two main processes. One is compaction, and if you are a cook or a baker and you've worked with brown sugar, you probably know that in order to measure it out correctly, you compact it or compress it in the measuring cup. So compaction is squeezing together of the material so that the pore spaces between the particles of that material are pressed out. Cementation involves the cementing together of the particles, and other minerals are the cementing agent. Calcite, silica, and iron oxide are common cements that form sedimentary rocks. This diagram illustrates the compaction and cementation of sediments. So the initial diagram, A, you can see that there are large pore spaces in that material. And through the process of compaction that occurs when new material is deposited over top, that's called overburden, it squeezes the pore spaces together. And then the remaining pore spaces are often filled with some type of mineral that acts as a cementing agent and cements the individual particles together. We're going to be looking at three types of sedimentary rocks in this lab. We're going to start part one, covers the clastic sedimentary rocks. Those are the ones that are cemented sediment. And then the chemical rocks is a different process, and we'll get to that. And the biochemical rocks, we'll get to that in the second part of the lab. But for the first part of the lab, we are starting with clastic sedimentary rocks. So clastic sedimentary rocks are formed when sediment is cemented together. The sediments come in different sizes. So we have gravel and sand, silt, and clay. The clay is the smallest and gravel is the largest. And each rock type that forms from these different types of sediment is often named after the sediment that it forms from. For instance, sand forms the sedimentary rock sandstone. Silt forms the sedimentary rock siltstone, and clay forms the sedimentary rock mudstone or shale, and it's often also commonly called claystone. Gravel forms a rock called conglomerate and also a rock called Arcos sandstone. And with that, we're going to switch cameras here and start looking at, some sedimentary rocks. I'm going to stop screen share. There. Oh, that's me. We weren't supposed to show me. We're supposed to show that, sedimentary rocks. Okay. All right, so these are the clastic sedimentary rocks that we're going to be working with. In addition to working with the rocks, you're going to need a worksheet or a Google Doc to do this lab. So I'm going to be using a worksheet just because of the ease with the camera. And the worksheet looks like that, Sedimentary Rock Lab. And then it has a data table on it, like that. So if you are working on a Google Doc, it is in your Google Classroom under today's assignments or when the assignment was given. Check Google Classroom for that. All right, so we're going to be recording initially the sediment size of each. So let's just take a look at what the sediment sizes appear like. And I'm going to move my rocks. And we'll start with clay. So this is clay. And it's basically the consistency of powder. You can see that it's on my fingers there. It's very fine, so you can't see the individual particles. Very, very fine material. And then we have some rocks that are made of sand. And if you've ever been to the beach, you know how big sand is. You can see the individual particles of sand. And then we're going to be working with gravel. Now, this is not obviously gravel like collected in the natural environment. This is something that you would purchase for a fish tank. But the important thing is to note that gravel, or the name of the sediment, refers specifically to the size of the sediment. So gravel are things that are larger, and clay are particles that are tiny, microscopic, and sand is intermediate in size. So we're not going to, in this activity, we're not going to actually measure the sediment size, but we are going to just compare them relative to each other. So yeah, so clay is very fine and gravel is larger and sand is intermediate. All right, so let's go ahead and pull these rocks back, and we need to identify the particle sizes. So we'll start with the ones that we can't see the individual particle sizes. So these here, I cannot see individual particle sizes, and the rock is very smooth because the particles are of similar size. This contains fragments that are much larger, as you can see there, fragments that are much larger. So that's gravel, and the gravel is intermixed with smaller materials, that's sand. And then this one, you can see that it's all pretty uniform in size, but there are sand-sized particles in that. Okay, so what we're going to do now is we're going to record the size of the particles on our document. So I'm going to once again move the rocks out. And there's my worksheet. And I'm going to identify particle size, sediment size. So each rock has a number on it. This one did have a number on it. This is number 1. And again, I need to remove that. So the lighting is better. So this is has been polished. The reason it's been polished is I bought this at Walmart, so it's a decorative stone. So I really doubt it was polished in the natural environment. This is probably mechanically polished, but I cannot see the individual particles. So this is clay. This one, number 2, and it is very similar to number 4 and number 3. You can see they're flat. I've got clay under my fingernails. They are flat in color or shape, but they are different colors. That's the dominant difference in them. Where they came from, let's see. Number 4, that's this one. Number 4 is local. I collected that at my parents' house in Fort Loudon. They live up against North Mountain. So locally, North Mountain is the mountain that's beyond Newburgh. So it would be very similar to rocks you would find in Newburgh. 3 and 2, 2 and 3, put them in the right order. I purchased from a pet store, and they were selling large fragments of this rock type for reptiles to warm themselves up on. And these were all the fragments, and I wanted the rocks for this activity, and I bought some of their pieces, and they were very happy that I did because, you know, they wouldn't have sold it otherwise. But all of these are the same type of rock, but they have slightly different mineral composition because, you know, that's evident in the different color. And for some reason I lost my focus. Okay. But the particles, you can't see the individual particles. They are clay. So we've got clay size particles for rock number 1, rock number 2. Let's spell it right. 3 and 4. They are all clay. All right, now let's go ahead and take a look at the other ones. 5, 6, and 7. All right. So we've already described this one, number 6. It has large chunks in it, which is gravel, with small sand. So gravel and sand in this one. Number 7 also has gravel and sand, and I'm having trouble getting it in focus here and for getting you to be able to see it well. I'm not sure where the best spot is. It seems like things that are light in color like this, with the lighting in my room, the fluorescent lighting, it's really bad, the lighting. But this contains gravel and sand as well. The main difference is this is rounded gravel, this is angular gravel. And then this is all smaller particles, but I can see the individual particles right there. That, if I hold it that way, you can see the individual particles there. That's sand. So we've got 5, 6, and 7. 5 is this one, and that's sand. 6 is this one, and that's angular gravel. And sand. And then this one, number 7, is rounded gravel and sand. Okay. All right, next, color and minerals. All right. All right, so let's go ahead and record the colors of each one. There's our, I'm gonna put the rock there. That doesn't work. Look, it's definitely the brightness of the paper affects that. Okay. Brown and gray are the colors for that one. Right. number 2, 2, 3, and 4. 2 is gray, 3 is red, 4 is brown. Gray, red, and brown. 2 is gray, 3 is red, and 4 is brown. All right. 5 is tan. 6 is kind of reddish or pinkish. It definitely has a reddish or pinkish tint to it. And this one is white to tan and gray. All right, so 5 is tan. 6 is red, reddish with some gray. And 7 is white, tan, and gray. Okay. All right. Now, possible minerals. Possible minerals. All right, so let's take a look at some minerals. A little review of minerals. All right, the minerals that are most prevalent in the Earth's crust are silicate minerals. So in our mineral identification lab, we identified several minerals: olivine, augite, hornblende, biotite mica, muscovite mica, plagioclase feldspar, orthoclase feldspar, and quartz. So now some of these minerals come in different colors. So these 3 can come in different colors. More so, these 2 come in lots of different colors. And these 2 are the 2 most common minerals that are present in the crust. And there's a lot of this too, as well, the micas. So we're going to focus mainly on these here, okay, as our composition. All right, so we've got mica, orthoclase feldspar, and quartz. Sand is primarily quartz. So if it contains sand, we're going to add quartz to it. And clay contains a lot of mica and also this orthoclase feldspar as well. So for our rocks that are made of clay, we're going to add mica. And we're going to add that orthoclase feldspar. The orthoclase feldspar chemically weathers into clay minerals. So when you did your chemical weathering lesson, you learned about chemical weathering and the chemical decomposition of orthoclase feldspar, potassium feldspar, into minerals like talc and kaolinite. So we're also going to add this. Okay. Now, sand is contains a lot of quartz. And we said there was sand in this, so there's going to be quartz in that. And we said there was sand in this, so there's going to be quartz. All right, so this is made of sand, and we're saying that it contains quartz. Does it contain other minerals? Probably, but we can't really tell. So we're going to say we're done with that one for now. This one, there's actually chunks of minerals here. I can see the actual chunks of minerals. The question is, what mineral is that? And we can actually identify that mineral. That is this, orthoclase feldspar. So there are chunks of orthoclase feldspar in that rock. All right. And then the last one right here, we've got pebbles and sand. It's kind of hard to tell what the actual pebbles are. I'm just going to leave it go with quartz on that one. And now it's time to identify those rocks. So the next paper you need is this one, your descriptions. This is also, if you're in my room, you have a paper copy of this. If you are only online, you have a virtual copy of this. You're welcome to use whichever one you want, those of you in the room. All right, so use this for rocks 1 through 7, so this side. So one of them is a conglomerate, one is quartz sandstone, one is Arco sandstone, 3 are shale, and 1 is claystone. So your task is to read the descriptions, match up the descriptions to the information that you recorded on your data table, and identify the rocks. So we'll just look for the first one. Conglomerate. Conglomerates are composed of a mixture of different size sediments, indicating the material was poorly sorted before it was cemented together to form rock. The particles range in size from rounded pebbles to sediments smaller than sand. These particles were cemented together by silica, calcite, or iron oxide. So we're looking for something that's a mixture of different size particles that has rounded pebbles and smaller particles smaller than sand. So rounded pebbles, mixture of different size, smaller than sand. So the question is, which one is it? Is it number 1, which is clay, made of mica and orthoclase? Is it this one, which is made of clay? Or this one, number 3, which is made of clay? Number 4, which is made of clay? Number 5, which is made of sand? Number 6, which is angular gravel and sand? Or number 7, which is rounded gravel and sand? It is the number 7, the rounded gravel and sand. So with that, you record conglomerate for number 7 and identify the rest of the rocks. So I'm going to stop this video here. Here are each of the rocks, so you can see them again in the video if you need to, while you are identifying these rocks.